As you're listening to this, there are over 8,000 satellites orbiting the Earth, whether satellites, navigation satellites, communication satellites for radio and TV broadcasts, and many others. But have you ever asked yourself how these thousands of satellites move through space without fuel? And if they do use fuel, what happens when it runs out? To explain, let's imagine we have a cannon placed on top of a high mountain, and we fire a shell horizontally. The shell will travel through the air for a while, but after a certain distance, it will fall to the ground due to gravity. Now imagine we had an incredibly powerful cannon that could fire a shell far enough that it escapes the curvature of the Earth. In that case, the shell would keep orbiting the Earth endlessly, continuously falling but never touching the ground due to Earth's gravity. This is the basic principle behind satellites. They don't actually need fuel to keep moving. When we launch a satellite, we place it on a rocket, which then propels it through the atmosphere until it reaches a specific orbit around the Earth. Once there, the satellite starts orbiting automatically, driven by gravity or momentum, in the same way the Moon orbits the Earth and the Earth orbits the Sun. So, does this mean satellites never need fuel? Not exactly. While they don't need fuel to stay in motion, they do require fuel for some essential tasks, such as taking pictures, sending and receiving signals, or adjusting their position. But of course, this isn't fuel like gasoline, as we can't just refuel satellites in space. We need a type of fuel with a very long lifespan, able to power satellites for decades or even hundreds of years. One of the most common fuels used in satellites is hydrazine. It's a chemical compound made of nitrogen and hydrogen, and even small amounts of it produce a very high-energy reaction. However, it's toxic and requires careful handling. Another method used for powering satellites involves nuclear reactors. For instance, the Voyager 1 space probe, launched in 1977 to study the solar system, is equipped with 3 radioactive power generators. It's still functioning today, sending signals back to Earth, and is expected to keep working until around 2030 or beyond. Lastly, there are solar panels, which are also used to power satellites and space probes. Some of the most famous space objects that rely primarily on solar energy include the International Space Station, the Hubble Space Telescope, and the James Webb Space Telescope. And that's it. If you ever have a question that keeps you up at night, drop it in the comments and we might answer it in future episodes. Many of the topics we cover come straight from your comments. See you next time